These old amplifier panels are a real classic in today's electrode technology age. Transformer coupled power amplifier. I mean, if we're working with valve guitar amplifiers, these are as common as, but in BJT, not so common these days. These were made for TAFE back in about 1985. Mount Druitt Technical College logo in the day up in the corner. Has two center tap audio transformers, one on the output and one on the input. Very simply constructed, two NPN transistors, so we have positive rail going to the center tap of the output transformer. That positive voltage goes through each half of the output transformer and appears on the collectors of each transistor. The emitters are tied together and almost go to ground, but they go through about a half ohm resistor on their way to ground. The bases go to the input transformer, and the center of the input transformer is connected to a voltage divider with 100 ohms on the top, 220 ohms on the bottom. You can see the oscilloscope waveform here in the picture, and at the moment it's showing severe crossover distortion. That's because I've intentionally wound the bias to a point where each transistor is not turned on enough to give 180 degrees of conduction. If I start to turn the bias up, the variable resistor is quite noisy because of its age. But if I turn the bias up and you look at the oscilloscope waveforms, you can see that the crossover distortion is getting smaller as we come towards full 180 degrees conduction in each transistor. So at about that point there, it appears that I've got no distortion on the output waveform, and because now I have Q1 180 degrees of conduction on one half cycle and Q2 180 degrees of conduction on the other half cycle. Of course, what will happen if I continue to increase the bias? As I continue to increase the bias on the transistors and we saturate the junctions, the output waveform again is quite distorted. You can see it's got different type of distortion this time. Finally, I'll take that back to the point where we have a good representation of our sine wave signal. I'm running at about 12 volts peak to peak on the output of the amplifier with a 12 volt rail. We've got no clipping, but if I do go to my signal generator and I increase the signal generator output voltage, and now you can see I've got very symmetrical clipping there on the output of the amplifier.